So let's solve one interesting numerical on the modulation index of the angle modulated signal. Till now we have seen that the message is a single tone, right? But here we are taking multiple tones. So the steps are the same. If you remember, the definition of modulation index is maximum frequency deviation divided by the maximum frequency component of message signal, and MFD means maximum frequency deviation of the angle modulated wave. So first let's try to evaluate maximum frequency deviation. For this we will first see what is the instantaneous phase. Instantaneous phase is very simple. You can just take the argument of this cosine. So that is your instantaneous phase of this angle modulated waveform. Then we will evaluate step 1. Step 2 is to evaluate the instantaneous frequency of this angle modulated waveform, that is defined as 1 by 2 pi d theta it by dt, and that you can do 5 cosine 2 pi 1500 t, and since you are differentiating it, firstly you have to divide by 2 pi into 2 pi 1500 plus 7.5 by 2 pi. This 2 pi is because of this, right? Then you differentiate this, and so this is the differentiation. This 2 pi, this 2 pi, and this 2 pi, those 2 pi get cancelled, and next step 3 is to evaluate what is the frequency deviation. Frequency deviation is instantaneous frequency of your angle modulated wave minus the frequency of your carrier wave. What is frequency of your carrier wave? 10 to the power 5. So if you write your frequency deviation, that is 1500 into 5, 7500, 7500 cos 2 pi 1500 t plus 7500 cos 2 pi 1000 t. So what is the maximum frequency deviation? This was your step 3. Step 4 is what is the maximum frequency deviation? So maximum is when it is 1 and simultaneous this is also 1. So and it is possible, right, that you can also write, you can see that it is the frequency is 3000, and so there will be a point where both of them will be 1, right, because it is having a frequency of 1500, this is having a frequency of 1000, it means its time period is 1 by 1500, its time period is 1 by 100. So there will be some points where both will be 1, right? That you can see, and if you plot it you can see. So the maximum of both will be 15,000 hertz, and what is the maximum frequency of the message signal, because this is a tone of frequency 1500, this is another tone of frequency 1000. So, the maximum frequency is component of your message signal is 1500 hertz. So, your beta is maximum frequency deviation divided by the maximum frequency component of your message signal, and so the answer is beta is 10. So, you have to just follow the steps and you can get the modulation index. Just you have to see what is the maximum value of this. So, this you have to make sure of. Thank you.